Guys, our what we call law of cosines. All right. So here are our steps on how to solve oblique triangle by SAS or cosine law. First of all, we're gonna draw and label triangles. So let's see this problem in here and see how we can work on this one. All right. You good? All right. So let's see. Let's read it in here. Logan, go ahead. Let's read number 65. Thank you.
A 113-foot tower is located on a hill that is inclined 34 degrees to the horizontal, as shown in figure 16. A guy wire to be attached to the top of the tower and anchored at a point 98 feet uphill from the base of the tower. Find the length of wire needed.
Thank you. All right. Okay. So we're gonna need to find the length of wire needed for such, right? So here is that mountain and that is 34 degrees, right? You good? Right? So with that being said, we're gonna consider now this right triangle for such, right? Let's consider this right triangle. You good? Right? So since this is the height or this is the tower in here, then that means what do you think is this angle in here? Knowing this is 34 degrees and that is vertical, right? What do you think is the relationship between this 34 degrees and that angle?
Right triangle.
They sum up to a right triangle or to a right angle, right? Which is 90 degrees, right? In short, they are what we call what? Complementary angles, right? So with that being said, if this is 34 degrees, how much do you think is this angle in here? If it's complementary to 34, 56. Very good, right? So that means this one already is now 56 degrees. Once again, why? Because this one, let's see, this is horizontal and that is vertical, right? So in short, if you add this angle and that angle, that will completely be a right angle, 90 degrees. Are we good? Right? Next one, it says in there, draw and label. So let's label this one now. Okay. Okay. Let's put in some letters in here. So here's what we're gonna do. What are we needing to find? We need to find this one, right? The length of that guy wire. So let's call it 1, 1. Small letter A, right? And let's call this one big letter A, right? What else? What do you think is this? What's this? 98 feet. What do you want it to be? Small letter what? C. Right? Or B, right? Whichever you want, right? So where do you think is big C? Up there, right? Very good. Now, this is now your what? Small b, and this is your b. Are we good? Right? So small letters for sides, opposite them will be big letters for angles. Are we good? Right? Next, can we read our step number 2 in there? Kendall, what does it say? Is it what? Is it SAS? So can we verify if this is side angle side? Well, let's see. You're given this first side. You're given this second side, right? And this angle you derive from that one, so that basically is almost given as well. And that is what? An angle in between those two given sides, right? So that is what? SAS case check. Are we good? Right? So two sides are given and an angle in between them. Get it? So it's not SSA, it's SAS. It's different. Because the angle in here is in between those two given sides. Okay? Let's read our step number 3. Krish, let's go ahead and read the question number, step number 3.
Use formula a squared equals b squared plus c squared minus 2bc cosine.
Thank you, right? We can consider that one as our SAS Law of Cosines formula, right? So we got it here. Small a squared is equal to what? B squared plus c squared, which basically is your Pythagorean theorem, right? You just basically add what? Subtract what? Twice these two given sides times the cosine of whatever this missing side is. As you may notice, whatever side you are measuring or you are trying to find out, the opposite angle to it should always be given. Are we good? So whatever is the first and the last should be the same letters. Are we good, guys? And plug in the values, right? And that basically is that. that one will be. Okay, what's this gonna be? Square root of, because you just want A, right? So you're gonna do the square root to get that side. What's your B once again in here? 113 squared plus, what's your C? 98 squared. We good, right? Minus 2 times 113 times 98 cosine of what angle? A, which is 56 degrees. All good, guys? So again, just make sure in here that you are using your Desmos on the same or on the right unit. So go here, click on degrees. Once again, your Desmos is typically by default in radians. So make sure it is in degrees. Get it? And plug it in here. SQRT. Okay. So let me just erase this part over here, guys, right? So that you can see on this side. Oh. I thought, okay, I'm erasing that one. There we go. Okay. So at least this part is black, right? And plug it in there, right? What's that gonna be again? 113 squared plus 98 squared. Here we go. Minus 2, 113, 98. And then cos, you can just type in cos as well. I'll go to functions, click on cos. And then 56. Get it, guys? 56. Again, make sure it's in degrees. Oh, a good number, right? So did it say round off the nearest integer or whole number, right? So how long should that guy wire be? 100. Did it say feet? Did it say feet? Right. Yep. Got it? 100 feet. Again, make sure that you click in here and see that that is in degrees. Are we good, guys? Questions regarding that? So with that being said, going back to the problem once again, then that means this guy wire in here, okay. So this guy wire in here should be how much? 100 feet long. Are we good? Questions regarding that, right? So once again, these are the summary of the steps, all right? First of all, label the triangles, okay? Small letters, big letters. Is it side, angle, side? Okay. Use the formula. Again, on your formula, whatever you're given, whatever your side is you're measuring, the angle opposite that should be given. Okay? Always what? Square root to solve for that side that you need. And always, once again, in here typically is in degree measurement, so make sure your calculator is in degrees, not radians. Again, your calculator, TI, and Desmos are both by default in radians. Make sure it's in degrees. Are we good? Right. Next one, Heron's formula, right? So let's read this one, and how can we do Heron's formula for such, okay? Okay, here we go. Number, what's this number? Number 77, all right? Let's read this one and see how we can use Heron's formula for such. Once again, number 77, okay? Let's read this one first. Kylene, go ahead, please. 77.
Find the area of a triangular piece of land that measures 30 feet on one side and 42 feet on another. The included angle measures 132 degrees. Round to the nearest whole square foot.
Thank you, all right? So again, we want to find the what? Area, right? So again, step number 1, draw, right? So let's draw this triangle. So we know that this is what? An obtuse triangle, right? Because of 132 degrees. So let that be 132 degrees. One of the sides is what? 42, right? So this is 42 feet. And the other one is 30 feet. So step number 1, we have labeled it correctly. Step number 2, is this SAS case? What do you think? Maggie, what can you say? Is this side angle side? Yes, it is, right? Very good. You have 2 given sides and 1 angle in between or included, right? So yes, check, it's SAS, right? Well, let's label it first. So if this is the missing side, let's call it A. We good? So this is big A, right? And these 2, let's call it what? Small b and small c. Get it? Okay, guys? So similar to what we did a while ago, right? What's the formula for this A? Square root of, right? Okay. Kendall, go ahead. 42 squared, right? Plus
30 squared.
Thank you. Minus 2 times.
42 and 30.
And then cos of 132, right? Again, take note that whatever side you are considering to solve, the angle opposite that should always be given. Are we good? Right? Well, just plug it in our calculator, just the same as what we did a while ago. Alright? So the good thing with our formula a while ago, we can just leave it as it is and just revise those numbers, right? So what are those numbers again? What do we need? 42, 30, 132, right? Okay, let's put it in here next time. 42 was in here. 30, so basically I'm just recycling what we did a while ago, right? 42, 30, and then in here, I'm going to change this to what? 132, okay? Okay, it doesn't hurt to actually go here and verify that it's in degrees, just to make sure. Get it? Okay. And what did we get? 65.9. So basically, approximately 66. Are we good? So there's basically a little bit of round of error in there, which is fine. All right. So let's just plug it in as what? 66 for now. Are we good? Right. So plug it in here like such. 66. Going back to the problem. Oops. Okay. So again, we solve our A to be approximately 66 feet. Okay. Now, how we're gonna get the triangle area? Interesting, right? Let's read that one in there, right? Step number 1. Let's read step number 1. Zach, go ahead. Is it?
Side?
Case, right? So in short, are the 3 sides given already or identified? Yes, at least, right? You are given 3 sides identified. So check. Step number 2. Let's read step number 2. Payola, go ahead. Let's read step number 2. What is
the semi-perimeter?
Thank you, right? So, let's change this color to, again, this is SSS case because you are given 3 sides, right? Okay. Semi-perimeter, that's called your S, right? S for semi-perimeter. Okay, so how much will that gonna be? Is that gonna be, right? In short, semi, meaning what? Half, right? Half of the what? Perimeter. So what's your perimeter, by the way? You just add those 3 sides, right? What's that gonna be? 42 plus 66 plus, what's the other one? 30. All right. Oh, what's that gonna be? What's your semi-perimeter? Or S? On your calculator, what's that gonna be, guys? 42, 66, 30. Sum it up all over 2. 138. All right. So I'm trusting you guys with this one. All right. Feet.
Divided by 2.
Oh. Divided by 2.
69.
60 what? 69? All right. Okay. Are we good? Right? Okay. What's yeah. So yeah. Yes, that is the perimeter. Semi means half. Are we good? Got it, guys? Okay. Well, we're almost done, right? Step number 3. Let's read it. Reagan, can you see it from there? What's the formula?
Use formula. Triangle area equals square root of S minus A, S minus B, S minus C.
Thank you. All right. So the semi-perimeter, 69 times what? 69 minus A. What's your A? 66. Okay. Same, 69 minus B, 42. And the last one, 69 minus, what's your C? 30. Get it? Okay, so again, just basically use the formula. Again, this is what we call our Heron's formula. It only works if you are having three sides already identified. Get it? So again, Heron's formula only works if you are given or you have identified the three sides, all of the three sides. Are we good? Right? So plug it in your calculator and get the answer in here, right? So, gonna put in here, square root, right? 69, parenthesis, what's that again? 69 minus what? What's A again? 66, right? 69 minus, what's the other one? 42, right? And the other one is what? 69 minus 30, okay? And what did you get, guys? Oh, what did you get? Square feet.
467.
467 square feet. Did it say rounded off nearest integer? Right?
Nearest whole number.
Nearest whole number or integer. Very good, right? 467. Once again, since this is area, it should be in square feet. Okay, square feet. So if you go back in here, here we go. So yes, that will be in square feet. So once again, summary for Heron's formula. All the three sides must either be given or identified already. And again, you can use SAS cosine law for the third side. Semi-perimeter, get the sum of three sides, get half of that. Hint, semi means half, right? Semi-circle, that means half of a circle, right? And the last one is use the formula for such. Are we good? All right. Thank you, Ola. And I'm gonna